nice and slow, is that it looks kind of like a ray from geometry, but it's not, because a ray starts and then it goes in a direction and it goes forever in a direction. And a vector, that arrow just is telling us what angle really the direction is going at, but it actually does stop. So I'm going to draw a picture of a vector. I'll call this P. This is its initial point. And then it goes off into this direction for a certain amount, or we call this the magnitude, and it ends at the tip of the arrow. We would call that the terminal point. And then I would call this vector PQ. I can't remember if it was half of an arrow or a full arrow.
I think that is half. I remember it.
Is the light blue hard to read? Would it be better if I switched to a little darker?
No. All right. So vectors, like I said, they have both, we call magnitude and direction. And so one of the things I'll ask you to do in a little bit is find how long magnitude, how long the vector is, and then find an angle for direction. But we should know some terminology. If I wanted to check if vectors were equal, we really use that word equivalent instead. And equivalent vectors are vectors that have the same length and direction. Now, as we get further on into the unit, we're going to actually find angles of direction. Today we're going to just use kind of their slope to figure that out. Because if they're sloped at the same angle, then they're going to be pointing in the same direction. Okay, so if the corresponding, if I said they're equivalent, to go a step further and say what makes equal vectors, that would be if the corresponding directed line segments are equivalent. Okay, so I guess what I'm going to do first is I'm going to show you how with ordered pairs we can do it, and then really mostly with vectors we're going to be looking at them in component form. Do you guys remember those brackets? They were kind of like almost like greater than or equal, greater than and equal to, no, greater than or less than signs. So I'm going to do an example. Let's let U be the directed line segment from R with coordinates -4, 2 to S -1, 6. And we're going to let V be the line segment from O, which is 0, 0, to a P, which is 3, 4. we're going to show that vector u equals vector v. Okay, so I am going to first right now, I can graph these and kind of take a look if you want. So if something started at 0, 0 and ended at 3, 4, it would look like this. Agreed? Okay. So this would be vector v. And then if I had rs, so that was negative 4, 2, and then it went to negative 1, 6. Okay. That was u. Okay, so at this point, I need to check their length and their direction. So do you first agree that they're both starting and they're going off, since I said from to, they're both starting here and they're going off to the right and up. Okay, so I am going to just compare the slopes of those segments to make sure they're at the same angle. So what would the slope of RS be? What would go on top? Oh. So how do you find the slope of something, Isaac? Yeah. Rise rhymes with y. So what goes on top? The y's. 6 minus 2 over negative 1 minus negative 4, which is, let's see, 4, negative 1 plus 4 is 3. You following? Okay. The slope of OP, well, that's nice. That's a 0. 4 minus 0, oh, yay. 4 minus 0 over 3 minus 0, correct? So are they sloped the same? Yes, okay, so we're going to say that's good enough for now. We are going to later on in the unit talk about direction angles. But for now, we know that they're going in the same direction. Now we have to show that they're the same length. So the way that we show that they're the same length is we're going to find their length, which is their distance. In vectors, the symbol for length is an absolute value symbol. I don't know if you remember that from before. Okay, so if I ever say, hey, absolute value, I just want to know, doesn't that make sense? Because doesn't absolute value really mean the distance from 0? Remember when we did that in algebra? So absolute value just means find the distance, and we're going to do distance formula for that. So the distance formula is you find the length of the x's and you square them. It's Pythagorean theorem essentially. The length of the y's and you square them, and then we go from there. Alexa?
Could you make them into a triangle and then find that side?
That's what I'm doing. Because it's Pythagorean theorem, isn't it? Leg squared plus leg squared, and then I'm going to take the square root to find the hypotenuse.
I just don't remember.
So I'm going to do negative 4 minus a negative 1 and square it, and then 2 minus 6 and then square it. Alright, we can do all of this without our calculator. What's negative 4 plus 1? Negative 3. What's negative 3 squared? 9. Okay. What's 2 minus 6? -4. -4 squared is 16. Is it 9 plus 16, 25? What's the square root of 25? Yep. Okay. So I was just doing the distance here. So Alexa, I was finding this distance by doing -4 minus 1. And I was finding this distance by doing 2 minus 6, because those are their y coordinates. Alright, so for OP, yes, this is going to be just, the x's is 3 minus 0 squared, or 3 squared. The y's 4 minus 0 squared, and we can quickly see that we get the same thing, don't we? Okay, and so I showed, once again, to show that they're equal, I needed to show that they had the same direction, so I did that by showing the slopes were the same, and that they have the same length, so I did that by using distance formula. So I did just show that U is equal to V.